Okay, today we're going to take a look at removing fractions, decimal, and parentheses from linear equations. So let's just get right into it and we'll take a look at a couple of examples. So if I have 2/5 x minus 1/10 equals 1/2, how do I go about solving this? Well, one way is just to do what I would do if this question didn't have fractions in it. Which is add 1/10, add the number and get the x's by themselves. So and I'll just show this in a different color, if I add 1/10 on this side, I have to add 1/10 on this side. You don't have to show that step. So this will be 2/5 x, keep my equal signs in a row, and now I have to do 1/2 plus 1/10, and to do 1/2 plus 1/10, I have to have a common denominator, so I'll go with tenths. And that's 5/10 and 1/10, which is 6/10, and I would reduce that to 3/5. So all that work to get to 3/5. And then I have to divide both sides by 2/5. Divide by 2/5, and the easiest way to do that is to actually write it out as a division statement. Divide by 2/5, that's the same as multiply by 5 over 2. Cancel a 5 on the top with a 5 on the bottom, and I get x is equal to 3 over 2. So all of this stuff on the side is just extra work, and I don't have to show that step in green, and that is perfectly acceptable. However, it's not the only way to do this question, so let's look at the exact same question and a slightly different approach. Okay, so whenever I have fractions, I can simply multiply each fraction, because I'm multiplying this side essentially by a number and this side, the right-hand side, by the same number. Just multiply both sides by the lowest common denominator. And in this case, that lowest common denominator is multiplying everything by 10. So if I multiply this by 10, it's really multiplying each of these by 10, and I also have to multiply this one by 10. So I'm doing 10 times 2/5 x minus 10 times 1/10. I'll show with brackets, and on this side 10 times 1/2, and it's really like 10 over 1. And so this 10 cancels this 5 and leaves 2, and 2 times 2 is 4x. And the 10 cancels the 10, giving 1, and so 1 times 1 divided by 1 times 1 is 1. And the 10 cancels the 2 and leaves a 5, so 5 times 1 divided by 1 is 5. And now I have a question that looks much more like a grade 8 level question. I can add 1 to both sides, and I can divide both sides by 4. And I can reduce to get 3 over 2, and just checking, yep, that's the same answer I had the other way, so it must be right. And of course there is a third way to do this question, which might seem like cheating as well. You can change everything into fractions, everything that is a fraction into a decimal. So 2/5 can change to 0.4x, and 1/10 can change to 0.1, and 1/2 can be 0.5. And now you can either use decimals to do your work, so add 0.1, or you can multiply everything by 10. Notice that's what I just did in the fraction method as well. I multiplied everything by 10, but multiplying decimals by 10 give you 4. Just move the decimal place over one spot, move the decimal place over one spot, move the decimal place over one spot, and then I can continue essentially from this step. So there's a number of different ways to attack these. Personally, I like the method where I have them as fractions and I multiply everything by the lowest common denominator. Of course, if it starts off as a decimal place, and we'll see some in a second that look like that, then you need to be able to multiply to get rid of the decimals. Okay, let's take a look at a couple more examples. So in this case, let's take a look at 0.002x minus 0.01 is equal to 0.03x minus 0.06. So if I use the move over the decimal place trick, this is needing to move to here, which is multiplying by 1,000. So if I multiply each term essentially multiply one side by 1,000, you got to multiply the other side by 1,000. Each term gets multiplied by 1,000. That moves the decimal place over 3 spots. And if I move it over 3 spots, I end up with 2x minus 10 is equal to 30x minus 60. And now I complete this question by moving all the x's to one side, moving the numbers to the other side. I like making all the x's positive, so subtract 2x on this side and subtract 2x on this side. Add 60 and add 60, and then divide by 28 and divide by 28. I get 50 divided by 28, and I reduce that. And you can flip the fraction around if you really like having, or flip the equation around if you really like having the algebra on the left-hand side. That's 25/14. Now, if you want to double check any of this, you could substitute that back in and see is the left-hand side equal to the right-hand side. If the algebra gets a little bit more complicated, i.e. the whole binomial 3x minus 1 is all divided by 5, and that equals 21 over 4. This is where I really like the power of multiply both sides by the lowest common denominator, in this case 20. And what ends up happening when you think about this as over 1 is the 20 and the 5 can cancel, leaving a 4. There's a common 4 between 20 and 4, which leaves a 5, and I really end up with a question that looks like 4 times 3x minus 1 is equal to 5 times 21. So in this case, I then use the distributive law. 12x minus 4 is equal to 105. I add 4 to both sides. That gives me 109, and I divide both sides by 12. And that gives me 109 over 12. And then you can check and see if 109 and 12 can reduce. And 12 is divisible by 2 and 3, 4 and 6, but those are both divisible by 2. So this isn't even. The divisible by 3 rule is if I can add up the digits, 1 plus 0 plus 9, and get a number that can divide by 3, then the original number could divide by 3. So it doesn't reduce, and I get 109/12 as a final answer. We'll do our next example right here. 4/5 x minus 1 equals 3/4 3x plus 2. So again, you can go and do distributive law and then work with fractions. Again, personally like clearing out the fractions, and that's not too much of a problem if you just remember that you can multiply by a common denominator, so 20 on both sides. Think about it as 20 over 1, cancel the 20 with the 5, leaving a 4, cancel the 20 with the 4, leaving a 5, and now you want to use the distributive law. And so 4 times 4 is 16, and x minus 1. 5 times 3 is 15. 3x plus 2. Make sure you don't distribute too much, so this 4 doesn't also distribute to this part, and the reason that it doesn't do that is because when you have multiplication, like 4 times 7, this 4 just multiplies to the 4, or multiplies to the 7. It doesn't multiply to both. It doesn't say 4 times 4 is 16 and 4 times 7 is 28 and multiply those two together. You can see you will have a number that is 4 times too big if you do it that way. So similarly, when I have 4 times this number, x minus 1, I really just want to do 4 times 4, 16, and then do a distributive law, 16 times x and 16 times 1. And on this side, 15 times 3x and 15 times 2. And then get all the variables onto one side, so subtract 16 and subtract 16, subtract 30 and subtract 30, and divide both sides by the coefficient. You can switch it around. Notice I've kept my equal signs in reasonably tidy row. And so I get 46, and 29 is prime, so it doesn't go into 46. And I'm done. Again, I think it's much easier, although we get a fraction answer, much easier to work when you're not in fractions and then come back and get a final answer That's a very similar method to what we've already seen in grade 8 and grade 9 than it is to try to work just with fractions all the way through. But it's your choice. You could convert it all to decimal places and work with decimals as well, but I think it's going to be a lot easier to work with whole numbers. We'll have lots of practice in class, and we'll see you there.